Okay, we've got to the top of the hour here. So here we go with session 3 of day 2 of the 2025 RNG Technical Symposium. I'm Paul Green. I run a biogas RNG advisory business and I drive the website biogas.tv. In this session, we're going to hear from Vergent Power Solutions about their offer into the biogas space. You can ask questions on the fly in the chat in the Q&A box, or we'll spend a few minutes on questions at the end. Later today, you'll get an email from me pointing to the slides from this talk on my website, and a video from all the sessions will be available at biogas.tv by the end of the week. So with that, I'll introduce speakers from Vergent. Mike Savage, VP of Business Development for Vergent, is responsible for crafting energy solutions focused on increasing profitability, expanding revenue, and minimizing utility expenditures. Mike has helped numerous customers fund their projects using a mixture of federal grants, incentives, and revenue-generating RECs, reducing project costs and maximizing ongoing revenue. Jesse Gillis, PE, serves as Vergent's Director of Projects, where he spearheads both the development and management of biogas initiatives throughout the US and Canada. Jesse specializes in developing high-efficiency biogas CHP systems, ranging in size from 65 kW to 1 megawatt, and optimizing these systems for the highest possible technical performance. So, Vergent friends, the floor is yours.
Perfect. Thank you very much, Paul, for the introduction. It's nice to be here today. Today we're going to talk about using microturbines to turn biogas and RNG into power and therefore use it to make some money. First and foremost, who we are. We are a developer of modular CHP systems, primarily utilizing Capstone microturbines. So we've done, many projects throughout Canada and the US utilizing different waste fuels such as landfill gas, digester gas, and dairy gas. And, we have, a fairly large fleet of several hundred microturbines operating, including one that's been operating on biogas since 2003. And the Capstone product ranges from 65 kilowatts up into multiple megawatts, which I'll go through in a second. In general, we'll provide the microturbine product, we'll provide application engineering support. In some cases, if needed, we'll provide a turnkey project, provide the gas conditioning equipment, all the controls associated with the project, and then all of the long-term maintenance. And our general area of service is the upper Midwest, New England, and Eastern Canada, although we will do projects nationally throughout the country. Why use Capstone microturbines? Well, there's a lot of advantages, and I'll run through a few of them here today. But first and foremost, it's a modular system. We use smaller building blocks of a 65 kilowatt or a 200 kilowatt system to build larger power systems. And that gives inherent redundancy. It allows us to shut one unit off to do maintenance while the other units continue to operate, allowing for extremely high uptimes and extremely high total system efficiency. It is a gas turbine, so it uses all of the, inherent benefits that large frame gas turbines have. And we, of course, have extremely low maintenance intervals. Typically, once a year, we change an air filter. We're able to turn the microturbines down and up, very quickly and easily while maintaining high efficiency. We're able to run on a variety of fuels. So in the example we'll talk about today, it's a landfill gas example that the fuel is pretty dirty, but we can, tolerate a fairly high level of H2S and certainly other particulates in the fuel. We don't need a building. We don't need sound enclosures. We don't need, extensive permitting, structures or anything associated with that. And the turbines themselves are inverter based, meaning that it's a very easy grid interconnection, meeting all the latest grid interconnection criteria such as UL 1741 and UL 1741 SA with all of the protective relay functionality built in. The emissions are extremely clean. Typically in the off-gas space, we find that our emissions are, a tenth of other technologies just due to the fact that it's a lean air to fuel premix and that it's continuous combustion. So we're not continuously lighting the fuel over and over again, but rather once the fuel is lit, it just stays lit definitely. And then finally, it is a product that's made in the USA. Capstone is headquartered of California. That's where their manufacturing facility is, and it has a fairly robust domestic supply chain. The turbine itself features a lot of inherent benefits. I'm going to talk about a few, but really the secret sauce of everything that we're going to talk about is built on air bearings. This air bearing technology basically allows for the one moving part in the system to spin frictionless with an air separating the two foil bearings, and basically that entire shaft spins on a cushion of air. That means there's no oil, there's no coolants, there's no lubricants of any kind. It's just naturally drawing air down the shaft and creating lift that allows the turbine and the two pole permanent magnet generator to spin freely on air. Capstone is the only company that does this. There's not any other companies that do this. And inherently, that single moving part spinning on the air bearings makes it a very low maintenance design, a very high reliable, product, and very easy to service. And then just for, the folks that are curious, the fastest speed we'll get the turbines up to is 96,000 RPM. So that's not 9,600 RPM. That's 96,000 RPM, getting close to 100,000 RPM. And therefore, at that point, obviously, you don't have any vibration, you don't have any friction of any kind. Otherwise, the system would self-destruct. For the purposes of how we handle a lot of our projects, and specifically in the biogas space, we like to use a modular approach where we use multiple units to build a larger power system. And in the biogas space specifically, this has a lot of additional advantages beyond just a conventional CHP project. And so you can see here in the photo, this system is a C1000 or a 1 megawatt enclosure, but it's got 5 independent 200 kilowatt modules. Each of those modules is capable of operating on its own. So it can operate without the other modules. You can shut one down to do service while the other modules continue to operate. And we can stage units on and off as needed to meet the load. And in the case of biogas, that includes the amount of gas that's available. So if, in the summer, there's lots of biogas available and we can run the system full out, but in the shoulder seasons, maybe we can only run 4 of the 5 bays. And then in the winter, maybe we can only run 3 of the 5 bays. It has that flexibility where with our control system, you can stage the bays on and off as needed based on gas supply, while also doing hour balancing and allowing for easy maintenance and all of that sort of stuff. So we do the same approach, whether it's with C65 microturbines, C200 microturbines. And, as I mentioned at the beginning of the discussion, we can go up to multiple megawatts. So where we have multiple sites that have multiple of these C1000 units together, allowing us to build a very modular power system that's very flexible for the needs of the customer and for certainly how much gas is available at any given time. The other thing I'll mention here is we can also blend in natural gas and other fuels such as hydrogen. So we have a lot of sites that, will blend in different amounts of natural gas depending on the year to maintain, that high output even when gas production is low, just for the fact that it may impact their demand charges and stuff like that. So I kind of want to spend the rest of my time here talking about a specific project that we did recently, and that's Lebanon Landfill in Lebanon, New Hampshire. This is a 100-acre landfill, and they've been collecting about 350 SCFM of landfill gas. Obviously, landfill gas, call it 40% methane, with the remainder being, other constituents. So the municipality really, about 10 years ago, started working on this, and so they started, collecting the gas. They started flaring, and they started looking for, things to do with the gas. And it took them 8 years before they actually landed on, microturbine based CHP as being the option that made the most sense. And they looked at, RNG into the pipeline, and they looked at other, waste gas to electricity technologies. And for, the benefits I talked about today, they landed on the Capstone microturbine product as being the preferred solution. Less gas conditioning is required than other technologies, and sort of, those things played a role. And so this project was installed recently. It's commissioned now, and its total project cost was about $6.6 million, including all the gas conditioning equipment, the microturbine, and then the turnkey installation provided by one of our project partners. So the system itself is able to produce 1 megawatt of electricity using a Capstone C1000 microturbine. We incorporated a microturbine interface module controller that's able to control the entire site, provide, real-time alerts, real-time data on anything that's going on. It's able to start and stop turbines based on available gas. And we also provided the gas conditioning skid through our partner Unison Solutions. So we when we go to do these projects, we look for partners that have the right fit. And in this case, Unison was definitely the right fit for the gas conditioning partner, providing the entire solution from start to finish, making sure that the gas does meet Capstone's requirements, and that includes dropping any liquids out of the gas, siloxane removal. There is an H2S vessel just for the compressors, and then the actual gas compression itself to feed the microturbine. The other two project partners we worked with on this project were Liberty Utilities, the local utility. We did have to do a fairly intense impact study due to the fact that there was multiple utilities owning a single substation in the area, and they did have a very specific interconnection requirement around being able to trip the systems offline in the event that they need to do work on the lines and stuff like that. But they were a great partner to work with. And then, last but certainly not least, Waldron provided all of the turnkey solution around the design and installation of the plant. And their technical expertise was definitely very helpful for, integrating all these complex pieces together into a single solution. With that, what was the result of what happened? Well, fundamentally, the microturbine can run, flat out. There's actually a little bit more gas than what was modeled, and we're able to run flat out all the time, at least right now, this time of the year, at a full megawatt, 1,000 kilowatts of electricity. Because the landfill itself can't use all of that electricity, they actually have a deal with Liberty Utilities where they can sell the power back and use it to offset electricity from other city facilities. So when the project's running full out, it offsets about 80% of the total electricity used by all of the city's other facilities, making it, a pretty dramatic ROI. So they do have, they're getting, about a 12% annual return on the investment. And it's expected that the plant, should be operational for 20 plus years. As I mentioned, the oldest microturbine we have operating on a gas similar to this is from 2003, and it's still operating strong. And then, of course, there's the greenhouse gas impact. The greenhouse gas impact being that it's gonna, over the next 20 years per year, offset 3,500 tons of CO2 from the greenhouse from the atmosphere per year. The one thing that you'll notice about this project that I haven't talked much about is heat recovery. That's because the municipality looked at heat recovery as a phase two. So the first initial phase was to get the site up and running, making electricity off of the gas, and kind of dealing with all these complex issues around, working with Liberty in these different issues I've talked about. And then the future plan was to operate with heat recovery. Because the microturbines have all their thermal energy in the exhaust and there's no oil or water jacket or anything like that, it's very easy to incorporate heat recovery later. So we can add heat recovery on a single C200 bay at a time and incorporate heat recovery back into heating the local facilities on the landfill site. Or we can common duct the exhaust together into a single stream, and then from there recover the heat and put it back into the building. On heat recovery, the last thing I'll mention is that there are multiple types of heat recovery we can do from the exhaust stream. It's not just hot water. We can incorporate an absorption chiller and do chilled water. So if there's a facility nearby that needs chilled water, we can get about 500 tons of cooling out of a single C1000. If there's a need for steam at a local facility nearby, we can produce a pretty significant amount of steam with a heat recovery steam generator. And then finally, the exhaust is clean enough that it can be common ducted into direct exhaust applications as well. So with that, unless there's any specific questions, I will pass it over to Mike.
Yeah, thanks, Jesse. So that's a pretty good overview of a traditional biogas to electricity projects. We our where we're active right now in the RNG space, you know, we're looking at projects for various developers, but I'll say, you know, we want to be a project partner. It's not just a one-way street where, you know, we want an order for equipment. We, you know, want to get involved. We want to refer projects that we're aware of. We want to, you know, we're creating offtake markets in, you know, ISO New England region for pipeline RNG. So we're, you know, we're trying to be a good partner and an active partner in the space. Where folks are having us look right now, I would say is 3 areas. The first is kind of optimization. So trying to lower your operating expenses. So your, you know, gas skids require a lot of power. And that's a big operating expense on the utility expense for power, for the grid power. So you guys are great candidates for what we do. You have a large load. It's a consistent load. You generally have, you know, low gas costs, whether that's, you know, if you're able to round trip that to us or pull off the gas pipeline back to us. So this is all assuming sort of using natural gas to make you power behind the meter for your gas skid or your, you know, your customers, the dairy, you know, that's attached to you guys, or that you're attached to them. So, you know, generally think of us when you're, you know, the grid costs are starting to creep up, whether that's, you know, in the Midwest and PJM or in New England, where we're, you know, various decarbonization initiatives are kind of increasing the price. So if that's starting to hurt, you know, give us a call. We can, you know, try and look at it. You'll get Jesse and me, and we'll, you know, try and figure out a solution and a way for you guys to save some money. We can, if you got money left in the CapEx budget, that's great. But if you don't, and you want to look at this on an OpEx kind of solution, we can do that. We're doing that right now, getting PPA and lease options in front of people. So we're doing this at a landfill gas site, and that's a couple megawatts, and we're gonna, you know, make as much power as we can for them. And the savings would, you know, are close to 300,000 a year. So, you know, put a multiple on that, and it's, you know, it starts to be pretty attractive. We're also hopefully going to be able to, you know, round trip the gas back to us. So that means, you know, we're basically buying, you know, we know you have to share the monies with on a royalty basis. So, you know, we can buy that, be a buyer of that gas on a long-term basis. And you'll have a portion of that hedged. And we could do this, you know, at digester sites too, using, like Jesse said, our thermal energy. And that only increases the savings because, you know, in a landfill, we're just, you know, sort of wasting that. So the savings will be even more than, you know, on a per kWh basis than what we could do on a landfill. And we might even lower your CI score, you know, if you're operating in a dirty grid like in the Midwest. So that's the first area, is sort of optimizing operating expenses. The second would be trying to create additional revenue. We can do this by trying to utilize any excess biogas you have. So, you know, you pick the size for your skid, and for whatever reason, you know, herd side's increasing, or it's just, you know, putting out more gas than everyone thought, or through your own efficiency in your gas skid process, you may have some excess that, you know, you just can't get through the throughput through your system, or and it's going to flare. In that case, have us look at it. You know, you're basically, you know, we're just a piece of equipment. We don't care if we operate on natural gas or biogas, but if we operate on biogas, you can basically turn us into a, you know, renewable power and thermal resource. And when you do that, you know, it opens up all the additional revenue streams, power recs, thermal recs, and things on the front end, grants, incentives, you know, doing all this stuff that states want you guys to do. And this could be an OpEx solution as well. So we're looking at this for landfill gas sites and dairy digester sites right now. And again, and who knows if, you know, E-RINs come back, but if they do, that's, you know, that's, you know, right there on a revenue stream with you guys on the RIN side. Next slide. Cool. And the last area I would say for RNG is where you're grid constrained. So this may be, again, where your customer is looking to expand, you know, the dairy, and they're adding more equipment, and or you guys are, and utility's just saying, we can't give you more power, or we can, and it's gonna cost several $1 million and it's gonna take a couple of years. So we see this all the time, for greenhouses that are in rural areas and, they get the initial greenhouse under glass and then they want to expand and then, the grid's saying we don't have any more to give. So, we see this, all the time and are looking at projects like this all the time. So, we can come in, we can operate in with the grid, we can be standalone, we can operate with a microgrid. So we're looking at a site right now. Basically, the utility's telling them, they need 800K more power. The dairy itself does, and the grid's, the utility's saying it's going to be a couple of years, a couple $1 million. So why not have a payback on that? With if you have the CapEx, or we can do an OpEx solution, as stated previously. So that's really where we're active right now in the RNG space. For end customers and engineers out there, go back to the biogas space that Jesse talked about, and that's really where, obviously a project is large enough, it's going to go, and you're near the pipeline, it's going to go RNG. But if it's on the smaller side, or it's stranded, or if the numbers just work for you, for a feed-in tariff or something, to make power with it, that's where we play every day. So, we'd love to look at those kinds of projects for any, the folks that are on the call today. And that's really it for where we play, where we'd like to go. As it's nice, for these customers to have RNG or biogas, but we sort of want our own. So we'd love to get into, the smaller, modular digesters that are just, put near feedstock, and we can get that and make power with it. And then obviously we'd love to do microgrids, at your sites, and incorporate the solar and batteries system with the microturbine. So I'll say that's kind of where we're playing. Think of us, give us a call. You're going to get Jesse and I to look at it. And let's just see what we can do. It doesn't cost anything to take a look. That's really it. Whether it's, I'll just summarize: the prime power need, optimizing the OpEx, or generate additional revenue. That's where you think of us. And you're going to get, guys that have been doing this for 10 years. We've got a lot of biogas sites on all different feedstocks. We, invite you to look at our website. It's got a list, has all of our microturbine projects, the locations, along with case studies. And if you ever want to visit a natural gas or biogas one, just contact Jesse and I. And we'll get you a site visit. But thank you.
Cool. Thanks, Mike. Thanks, Jesse. Appreciate it. So I had a couple questions come in here. Is your thermal to electric ratio similar to gas turbines, or how does that measure up?
Yeah, the thermal to electric ratio is about 2 to 1. So for every 1 unit of electric, you're going to get about 2 units of thermal. And so if our electrical efficiency is in the low to mid 30s, then your thermal efficiency is typically around 60%, leading to a total system efficiency of 90 percent-ish. Obviously depends on the type of heat recovery and stuff like that.
Okay. Next question: what is the OpEx per year of the 1 megawatt project case study that you showed us?
So on the microturbine side, the OpEx is around, I think it's a little less actually the site, but around 2 cents a kilowatt hour. And then you've got your media changes and stuff like that would be required on the gas conditioning skid. I think we typically see all-in costs of 3.5 cents kilowatt hour all in with the media and all of the other components of the conditioning skid systems.
So the 2 cents for the Capstone unit, what is in that?
Yeah, that's an all-in plan. We call it a factory protection plan. It includes all scheduled and unscheduled maintenance, including overhauls, and that's parts and labor. So that's an all-in number that no matter what happens, it's going to be fixed and it's included in that plan. Obviously, we have lesser options that may, only include scheduled maintenance or whatever it may be. But that 2 cents is kind of the top plan that includes everything, scheduled, unscheduled, parts and labor, including overhauls.
And what's the frequency? What's the interval for major overhauls?
Every 48,000 hours of continuous operation. So, call it 5, 6 years type thing. And that's really, you're getting a whole new turbine at that point, because it's that power head that I talked about, the air bearings, the single moving part, all of that is included in the overhaul, as well as the combustion liner and the fuel injectors. So that's the bulk of the system. And then as well, in terms of other maintenance intervals, we change an air filter once a year, every 8,000 hours, and then we change the combustion liner and the injectors every 24,000 hours. So once a year is a very minor 2-minute thing for air filters. Every 3 years roughly of continuous operation is a few hours of the work maybe per turbine, and then the overhaul maybe a 4-hour thing every 5, 6 years at 48,000 hours. And again, it can be done one at a time. So if you have multiple turbines at a site, you only have to shut one off at once to do service.
Okay. Do you recover heat in the exhaust gases?
Yeah, so all of our thermal energy is in the exhaust. So if we want to recover waste heat for a site, which 99% of our projects recover waste heat, we feed the exhaust into either a heat exchanger to make hot water, or an absorption chiller for chilled water, or a heat recovery steam generator for steam, or directly into an oven for a direct exhaust application.
Okay. And what is your H2S spec for your unit? What's the max you can tolerate?
5,000 parts per million.
Wow.
Yeah, fairly high in this space.
So that kind of leads me to the general question. If you wanted to leave the guests here with some takeaways on, engines versus fuel cell versus microturbine versus linear generator, how can you give us some leave behinds here on, okay, microturbine, when is the best time to look at the microturbine compared to other generation approaches?
Yeah, so all those technologies obviously have their, their positives and their negatives. Certainly if you're operating a significant part of the year, call it, 6,000 hours or more a year, you're going to find the microturbine product is uh, an extremely good option, just for the fact that that low maintenance interval, you're never going to get caught into the high OpEx costs that you'll get with, some of those other technologies you mentioned. Also the reliability aspect, our sites operate 99.5% uptime per turbine. So the whole site, is typically around 100%. And then, you might have a shutdown here and shutdown there per turbine, but that's much higher than a lot of those other technologies you mentioned. Emissions is another big one. Our emissions are extremely low. The turbines on natural gas are CARB certified in California, as an example. So if you have a strict emissions criteria, that's without any after treatment whatsoever. So we're not doing any catalysts or urea or SCRs or anything like that to accomplish it. And certainly, like I said, that if you get to a point where that OpEx becomes the killer on some of these other technologies, when you get into operating 8,000, 8,760 hours a year.
Okay. So last question here ties into the point you just made. So to the point about SCRs, the guest was asking, do you supply SCRs, but do you not require them?
Do not require them. We do have a passive catalyst option that we will supply that deals specifically with CO, carbon monoxide, but that's, for very rare projects, such as in greenhouses where we're direct exhausting into the greenhouse, where we need to be able to have the exhaust as clean as possible. But yeah, we don't do SCRs, and not needed in any jurisdiction that we do business in. Like I said, including California, and this project in New Hampshire is another example. They have pretty tight air emissions requirements there, and we were well within the limits.
Great. And where are you guys from? Where do you guys sit?
We have offices in Boston, Minneapolis, Toronto, Ann Arbor, Michigan, Washington, D.C., and Houston, Texas.
Very good. Okay, that's the extent of the questions that came in. So thank you, Vergent. We appreciate that. And Microturbines certainly is one of the established workhorses out there for long-term durability, reliability. So I'd encourage all the guests here to give you guys a shout if they've got a potential electric generation project. So Mike, Jesse, we'll let you guys run. Thank you for joining us today.
Thank you, Paul.
Thank you, Paul. Thanks, everyone.
So we've got a break in the action till the top of the hour. In 30 minutes, we're going to hear from Clark Energy about combined heat and power integrating with a RNG gas upgrade or with CO2 recovery on that. So we'll look forward to seeing all you folks in 30 minutes for session 4.